Yesterday, we looked at three new terms, including time, speed, and velocity. Time is a vector or a scalar. Yeah? Good, it's a scalar. There's no direction associated with time. Notice we put the delta t there. Delta means a change, right? So we're talking about usually in physics a time interval as opposed to a specific moment in time. In physics, we don't usually care that it's 9:11 a.m. We usually care that 4 minutes have gone by during an event or 30 seconds have gone by during an event. Next term we learned was speed. Speed was given by the symbol v. Is speed a vector or a scalar? Yeah, Luke? Good, it's a scalar. There's no little vector sign over top of it, and we know there's no direction associated with speed either. You guys know the units for speed? Yeah, go ahead, Luke. Good, it's going to be meters per second. At least that's going to be the standard unit for speed. What about velocity? Vector or scalar? Ariel? Good, it's going to be a vector. We see the vector sign over top of it, and we also know that there's a direction associated with velocity. When are speed and velocity going to be the same number? Like when, if I'm driving my car, when is my speed the same number as my velocity? Yep. Good, when I don't change direction, just like distance and displacement were the same number when I didn't change direction. Now, of course, velocity has a direction associated with it, so it's always going to be different than speed, but it couldn't be the same number as long as we don't change direction. There were two equations that we learned yesterday, one for speed, v equals delta d over delta t, which technically doesn't appear on our data sheet, but then there's the one for velocity that's almost identical to it, which does appear on our data sheet. Distance over time and displacement over time. You guys know how to find distance and displacement, right? Sometimes we find it by adding numbers together. What do we have to add together to get total displacement? We just had a quiz on that this morning, right? Maddie, what do we got to add together to get displacement? Your distances or displacements, right? So if I walk 10 meters to the west and then 5 meters to the east, I've got to add those numbers together to get the total displacement and then divide by t here. So we add displacements, or in this case, we'd add distances, right? What are we going to subtract in order to get the total displacement in order to plug it into the v equals d over t equation? Erica? Yeah, we're going to subtract position. So it's going to be not delta D there, but dF minus DI. Again, that's review for the past 4 days or whatever, right? Since we've been here, we've been talking about distance, position, and displacement. We good there? Now, there's going to be a question later on in your worksheet. We're going to check over the first 4 questions in your worksheet here now. There's going to be a question later on, though, that I want to address right now. Okay. When we look at these two equations, let's focus on this one right now, okay? Look at these two equations, particularly the second one there. Always remember that the velocity, the average velocity, is always the total displacement over the total time, or in the case of speed, the total distance over total time. If I want to find an average speed or an average velocity, again, listen carefully because this is going to rear its ugly head shortly after we finish going over questions 1 to 4. If I want to find the average, you got to be careful not to find the average the way that you might typically think of finding the average. Okay, if I said Christine has $20 and Christian has $30, the average of their money is $25, right? Make sense? Okay, that's how we average. We add them up, divide by 2, right? But listen to this one. If I drive to Edmonton, a distance of about 340 kilometers, if I drive to Edmonton at 110 kilometers per hour, but then I stop in Red Deer for a drink at McDonald's on the way up, I'm only there for 5 minutes at rest, right? My car's not moving for those 5 minutes. Right? For 3.5 hours, my car is moving at 110 kilometers per hour. For 5 minutes, my car is at rest. What's my average speed? 55 kilometers per hour, right? 0 plus 110 divided by 2. Is my average speed 55 kilometers per hour? Of course not, right? It's certainly more heavily weighted towards the 110 kilometers per hour, right? So how do we figure out exactly what the average is? We got to get the total displacement for the entire trip and divide it by the total time, and that will give us our average, our weighted average. Does that make sense? So when you're finding average speed or average velocity, don't ever just add them up and divide by 2 like we added up Christine and Christian's money, right? Rather, we're going to get the total displacement and the total time and then simply divide them just like we did on those 4 questions on the worksheet. Speaking of those 4 questions on the worksheet, let's take a look at those now. Let's go through these. We'll go through all of these fairly quickly here just because they're all fairly new to us here. First question says a 1,500 kilogram car. Hey, what relevance is that mass of that car? None, right? Mass later on this year is going to matter to us. When we talk about what causes motion, mass becomes really important. But when we're talking about the motion itself, it doesn't matter whether a semi-truck is traveling at a certain speed or a smart car is traveling at a certain speed. Hey, the motion is the motion. Anyways, this car is traveling from Okotoks to Calgary, distance of 35 kilometers in time of 30 minutes. What's the average speed of the car? We're going to say my distance here is 35.0 kilometers. And my time here is 30.0 minutes. Now, some of you yesterday left it as kilometers and minutes, and that's okay. If you did that, solving for speed, then you should have done something like this with the equation. 35.0 kilometers divided by 30.0 minutes. Who did it that way? Kilometers and minutes. Jack, what did you end up getting there? Okay, 1.16. What did you say after that? Good, kilometers per minute. Now that's a pretty odd unit for speed, right? I don't know that I've ever heard kilometers per minute used, but it's correct, right? And you can express it that way, and I'd mark it 100% correct on a test. Most people, however, did it this way. Most people said speed is distance over time, just like Jack did, except they converted time to hours. 30 minutes divided by 60, because there's 60 minutes in an hour, gives me 0.500 hours. That gives me, when I do the math there, 35 kilometers divided by 0.500 hours gives me 70.0 kilometers per hour. Those numbers make sense? If you're going 70 kilometers in an hour, well, you're going significantly less than that in a minute, right? Well, look, I got 70 kilometers in an hour. I got 1 kilometer in a minute. That seems reasonable. Both of those are correct. If that was a quiz, both of those would get a 1 out of 1 or a 2 out of 2, whatever it was out of. Okay. 2, light travels at an incredibly high speed of 3 times 10 to the 8 meters per second. Calculate how far the light will travel in 1.0 hours. I don't know what this number is, but I know it's really, really big. Okay, this is about 1 billion kilometers per hour. So if light travels 1 billion kilometers per hour, like about 1 billion kilometers per hour, obviously in 1 hour, you're going to get about 1 billion kilometers. Okay? I don't know exactly what the number is, but it's big, really, really big. All right, what do we got here? We got a speed of 3.00 times 10 to the 8 meters per second. We got a time here of 1.00 hours. We're looking for, what are we looking for? The distance. This one's a bit tricky in 2 ways. One, we got to rearrange the equation, right, Ethan? Got to rearrange the equation to solve for distance. How do we do that? How do we do that? Ben, how do we rearrange this to solve for distance? How do we get rid of that t? Yeah, take time, multiply time on both sides, which ends up looking like this when all is said and done. Right? The time ends up going up on the top of the other side. Multiply by t. Okay, good. It's the first thing we had to watch out for. What's the other thing that we got to be careful of? Max, what else you got to be careful of here? Yeah. Good, good. Exactly. We got inconsistent units here. Now, I don't care whether you use hours or seconds, but you got to be consistent, right? Meters per second and hours don't work with each other. I think the easiest way to do this is to convert hours to seconds. We're going to multiply it by 60 to get minutes. And then we're going to multiply it by 60 again to get seconds. So that's going to end up being 3,600 seconds. Now we're consistent, right? Meters per second and seconds. So what is that? 3 times 10 to the 8 times a time of 3,600 seconds, which gives me, let's figure this out here. Gives me exactly 1.08 times 10 to the 12 meters. So just over a billion kilometers. Okay, 1.08 billion kilometers. Good. How many people got that one? Good. 3, the average braking reaction time for a driver, which is the time between when the driver recognizes that he needs to stop until the time that he actually applies his foot on the brake, was found in 2001 to be 2.3 seconds. So let's try to understand what's going on here, okay? When you put your foot on the brake, after you put your foot on the brake, it takes a certain time and distance to stop your car. Like your car doesn't stop instantly, but it takes time to even get your foot to the brake, right? You see the obstacle on the road in front of you. A number of years ago, I was driving along this river in outside of St. John, New Brunswick, 5 o'clock in the morning. I come around this corner, and there's this entire family of raccoons on the road in front of me. And it's like slow motion. I went to put my foot on the brake. They move it over to put my foot on the brake, and didn't quite get it there in time. Smoked the entire family of raccoons. Dut, 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 dut. On average, like we don't even begin to slow down for 2.3 seconds. And then once we do start slowing down, it still takes longer to actually stop. Let's see how far you will go traveling at 90 kilometers per hour before you even begin to slow down after you see that family of raccoons. We got a time here of 2.3 seconds, and we have a velocity or a speed of 90 kilometers per hour. Let's find the displacement here. Really, it should be distance probably because we have direction, don't we? Yeah, north. All right. What's our issue here? What's our issue here? Yeah. Yeah, we got inconsistent units again, just like Max pointed out last time, right? He said, I think last time it was meters per second in hours, right? This time it's kilometers per hour in seconds, but it's still inconsistent. You got 2 choices. You could change that seconds into hours by dividing by 60, gives you minutes, divide by 60 again, gives you hours. Or you can convert kilometers per hour to seconds, to meters per second. I think that's what I'm going to do here, just to demonstrate how to do that. 90 kilometers in 1 hour. 90 kilometers in 1 hour is the same as saying 90 times 1,000 meters per 1 hour or per 3,600 seconds. So 90 times 1,000 divided by 3,600, kilometers to meters, hours to seconds, gives me 25 meters per second. So let's say V equals D over T. Take the T up by multiplying. I get V times T. What is that? 25 times 2.3. Gives me 57.5. And it's positive, which means it's to the north. Make sense? So let's revisit that again. 57.5 meters. Like you're going at 90 kilometers per hour, which is still 20 kilometers per hour under the speed limit on the highway. And you see an obstacle on the road, a deer ran out in front of you, or a kid ran out in front of you. You travel 57 meters before you even put your foot on the brake. You travel more than half a football field before your foot ever gets to the brake. So when you wonder, like, why do you have to go so slow in a school zone? Why can't you go 90 in a school zone? Because a kid runs out on the road and you've just traveled 58 meters before you even put your foot on the brake. And then it still takes you a while to stop once you get your foot on the brake, which means it's probably going to be too little too late. Okay, finally, number 4. It says downtown Calgary is 61 kilometers north of High River, while Okotoks is 15 kilometers north of High River. Drive from Okotoks to downtown Calgary in 45 minutes. What's your average velocity? From downtown Calgary, from Okotoks to downtown Calgary. Let's say position 1, Okotoks, is 15 kilometers north of High River. Calgary, downtown Calgary, is my final position because I'm going from Okotoks to Calgary. That's going to be 61 kilometers north of High River. This is so far just like our quiz question, right? Our reference point is High River. Doesn't really matter what my reference point is as long as I'm consistent. Time is 45 minutes here. We want to find the average velocity. Do we have to change units here? Tino, do we have to change our units here? Kilometers, minutes? No, we don't have to, do we? If we don't change our units, so what are we going to end up with for velocity? What's our units going to be for velocity, Blake? Kilometers per minute, which is not normal, right? But it would be okay as long as you specify that. I think I will convert. Yeah, I think kilometers per hour sounds better to me. It's no more right, but it sounds better to me. So I think I'm going to convert this to hours. 45 divided by 60 gives me 0.75 hours. How many people did convert when they did this question? Okay, how many people left it in kilometers and minutes? Okay, either way. What's my displacement here? We're going to say 61 kilometers minus 15 kilometers because it's final minus initial position. So what's that going to be? 46 kilometers divided by 0.75, 61.3, 61 kilometers per hour. Positive, so it's to the north. If I had asked you for speed, what would the number have been? What would average speed be here? Quick, 3 seconds. 1, 2, 3. What's the answer? Same answer, right? 61 kilometers per hour. How do you know it's the same answer there, Grayson? Because it didn't change direction, right? Make sense? Okay. I'm going to give you a little bit of time here to work on questions 5 and 6. Okay, but let me just give you a little bit of a pointer here before I set you free here. Okay, I mentioned to you before to find the average speed and the average velocity. What you don't want to do is say, okay, my average speed was 0 for part of it. My average speed was 110 for part of it. Let's just add them up and divide by 2. Okay, we don't want to do that. Average speed is always distance over time. Get the total distance, get the total time, and then divide them. Make sense? So in question number 5 here, what you're going to need to do is find out what that distance is. Find out what this distance is. Add those two distances together, and then divide by the total time. Okay? Let's start working on that. I'll take a walk around, and you can let me know if you're struggling with this, and I can give you a hand, okay? All right, everybody have a look up here. We're going to take a look at question number 5 together. It says, a jogger runs 5 kilometers north in 25 minutes, stops for a break for 10 minutes, then runs 10 kilometers south in 53 minutes. Excuse me, what's the jogger's average speed and velocity? Let's You know, let's write down all our givens together for question A and B. There's no point in writing it out twice. Okay, it's the same givens for both. So let's say in the first stage, my displacement is 5 kilometers, and my time is, we'll say time 1 is 25 minutes. In the second stage, my displacement is what? My time in the second stage is 10 minutes. What's my displacement in the second stage? 0. It didn't move. We stopped for a break, right? My displacement in the third stage ends up being negative 10 kilometers, and my time is 53 minutes. So if I want to find the distance, sorry, the speed, I want the distance over the time. What's my distance traveled there? It's my total distance traveled. Again, be careful. Be careful you don't do 5 over 25 to get the speed, then 10 over 53 to get the speed, and then just add them up and divide by 2. That doesn't work. I got to take my total distance, which is 5 kilometers and 10 kilometers, 15 kilometers. Didn't pay attention to the negative because we're talking about speed. Divided by the total time, which is, what, 25 minutes, 35 minutes, 88 minutes? You want to make that hours? You don't have to. We can leave it as minutes if we want, but I don't know. Kilometers and hours sounds better to me. So let's say 88 minutes divided by 60 gives me 1.466 hours. And we divide those two, we get 10.2, or we'll just say 10 kilometers per hour. Make sense? Yep. It would have been what? 78 minutes? Oh, did I add wrong? No, it's 88 because we have to include that 10 minutes right there. Right? If we're finding the average speed for the entire trip, that includes my stopping time, right? I used the analogy of yesterday, I believe it was, of when I was driving out across Canada the first time. Got to Regina, saw that sign that said Calgary 750 kilometers away, and at some level I was in my mind calculating, oh, it's going to be about 8 hours. Okay? Because I figured I would average about 90, 100 kilometers per hour, right? But I have to include anytime I stop there, right? If I stop for 2 hours, well, then my average speed is going to go dramatically down, right? Because it counts. That time counts. All right. My average velocity, don't need to write those givens down again. All we got to do this time is add these numbers up in a different way. Instead of being 5 plus 10, it will be 5 plus negative 10 over the total time of 1.4667 hours. So we get negative 5 kilometers over 1.4667 hours. And what do we get? 3.4? Negative 3.4? Why are my numbers different? Yep, venture. Because I changed direction, right? Because I changed direction. You ever forget that? Like, think of the track example that we've given you a few times, right? You walk around, you run around the track once, your distance is 400 meters. You run around the track once, your change in position is, or your displacement is 0. Right? When we change direction, our distance and displacement, or vector and scalar, are different numbers. Okay, let me give you a little bit of time to work on question number 6 now. And then we'll take a look at that one when everybody's finished. This one's a little bit tougher because this one we don't have the distance in the first stage and the distance in the second stage. We've got to get it. So a little bit more work, but same kind of idea as the last question was. See what you can do, and then we'll take a look in a few minutes here. Okay, we're taking a look at question number 6 here. It says a car travels 90 kilometers per hour east for 10 minutes, then 100 kilometers per hour west for 30 minutes. Calculate the average speed and the average velocity. Once again, we'll just write down all our givens together. We'll do it once. Then we don't have to repeat it for question B. We're going to say in stage one, and there is two stages here, right? We see the word then, which kind of tells us like, look, something happens as one problem, and then there's another problem. We're going at 90 kilometers per hour, and then we're going at 100 kilometers per hour. So let's say my velocity one in stage one is 90 kilometers per hour. We'll make east positive, so that's positive 90. And we're going to say that delta T1, the time in interval one, is what? 10 minutes? Now, we got to be consistent here. So you either got to convert that to kilometers per minute or convert the minutes to hours. I would suggest it's probably easier to convert the minutes to hours. 10 divided by 60, because there's 60 minutes in an hour, would give me, I think it's 0.1667. All right, good. There's my velocity in stage one. There's my time in stage one. Good. Let's worry about stage two now. Now in stage two, we're going, let's change the color up of this here. In stage two, we're going to say my velocity is negative 100 kilometers per hour. And we're going to say my time interval is 30 minutes, which ends up being 0.500 hours. Good? All right. Remember what we said? In order to find the average speed, we need the total distance divided by the total time. I don't know what the distance is. I saw a couple of people say 90 plus 100. It's 190. That's my distance. You can't just add speeds together to get distance. My distance is going to be delta D1 plus delta D2. Right? We got to add this distance to this distance. So let's do that. First of all, let's write down D is equal to V times T. Remember where that comes from? V is equal to delta D over delta T. Multiply both sides by T, and I get D is equal to V times T. So my distance in my first stage here is 90 times 0.1667 hours. What does that give me? 90 times 0.1667 hours. 15. My distance in my second section actually, you know what? Let's get, let's just call it displacement in both sections, and then I'll worry about the distance. The displacement in the second section is negative 100 kilometers per hour times a time of 0.500 hours, which gives me negative 50 kilometers. Okay, now that I want to find the average speed, the total distance will be what? Yeah, like 65 kilometers. Does that make sense where that distance came from? We always need distance, the total time. We had to get the distance from stage one, then the distance from stage two, and then we got to combine them just like we did in all our other questions. My total time, by the way, would be 0.667 hours. So 65 divided by 0.667 hours, 97.5. We'll say 97.5 or 98 kilometers per hour. Make sense? Hey, can anybody tell me why? I asked this question of a couple of people already, but ask it of all of you here now. Can anybody tell me why I got 98, which is closer to the 100 than it is to the 90? Like, I got 90 and I got 100. Why is the average closer to 100 than it is to 90, Venture? Exactly. You go 100 kilometers per hour for longer than you do for 90 kilometers per hour, right? If you went 90 kilometers per hour for longer, then your average would be closer to the 90. Good? Okay, now we don't have a lot of work to do for velocity. For the average velocity, all we're going to say is its displacement divided by the time. And the displacement here will be 15 plus negative 50, or negative 35 kilometers. add the displacements. You got to pay attention to direction here for this, though. Time is 0.667. I want to say 35 divided by that. 35 divided by 0.667. 52.5 or 53 kilometers per hour. Oh, wait. Oh, I did make a mistake, but I caught it myself. Barely, though. What was my mistake? Yeah. Yeah, I need that direction in there, right? Negative 35 kilometers, so it's negative 53 kilometers per hour. Or you could say 53 to the west. Good? Good there? It's coming, right? It's coming. Compared to what we knew here, well, this is only the fourth day of class. Compared to what we knew 4 days ago, we're doing pretty good, actually. All right. Good news is we don't have any time to start anything new, so I guess that means no homework for you tonight.